Let's talk about the data toolset. Here is the objective slide. Please pause and read it before proceeding. In this lecture, I'm going to give you a survey of the many tools that data professionals use at a high level. Let's talk about the programming languages I will be teaching you in DSci 2000. SQL is a programming language used to pull data from databases. I prefer SQL over SQL. How it's actually pronounced is up for debate. SQL has many different dialects. More specifically, in this class, I will be giving you access to a production-level SQL Server database. You will write code in Transact SQL or T-SQL to pull data from this database. T-SQL is one extension of SQL. Another type of SQL database is an Oracle database, which uses a different extension of SQL called PL/SQL. In addition, be aware that there are many other databases and extensions of SQL. For this class, make sure you are at least aware of SQL Server versus Oracle and T-SQL versus PL/SQL. R is a programming language that has its roots in statistical computing. It tends to be used more in the statistical world as opposed to the software development world. In the software development world, Python is more popular. R is built on top of C, Fortran, and R itself. Since we're talking about R, I should mention that anecdotally, there are more people who use Python in data science than R. Anecdotally, I suspect it's that data scientists consist primarily of people who come from computer science as opposed to statistics. Personally, I believe R and Python both have their advantages and disadvantages. I've learned data manipulation in both R and Python, and can say that working with both is just a matter of very simple translation of syntax. It's when you start going beyond data manipulation, say to more sophisticated statistics or machine learning applications, that their differences become more pronounced. Discussing this is above the scope of DSci 2000, but feel free to contact me to discuss more. Now let's talk about the different types of software. R is an example of what is termed an open source programming language, and T-SQL is considered closed source or proprietary. To explain what open source and proprietary mean, here's a table of qualities that these two different types of software tend to have. The actual difference between open source and proprietary is that open source code is publicly available, whereas for proprietary software, the code is not available. You can actually go online and find the underlying code behind R. You can't do the same with T-SQL. Open source tends to be downloadable, free or cheap, and people can usually make modifications to it quite easily. For open source code, you usually have to rely on online communities to provide support. Proprietary software tends to require a paid license, and tends to be expensive. Since proprietary code is not available online, no public modification of it is allowed, but with a lot of proprietary software, there's usually a company with a dedicated support team behind it. So R is open source. This is both a blessing and a curse. People can add their own code to R quite easily. Good from a developer's perspective, but from a user's perspective, it makes it difficult to standardize code, given that people are constantly developing code in R. As a side remark, Python has the same problem too, should you learn it for data analysis. Proprietary products tend to have point-and-click interfaces and are usually quite resistant to change compared to their open-source counterparts. However, at the same time, in my experience, open-source software tends to have a lot more flexibility with how you can construct output compared to proprietary software. The question then becomes how much time will it take, and do you have the technical background to make the software do what you want it to do? I'll elaborate on this in a bit. Here are some examples of open source and proprietary products in the data world. For the quiz, if I give you the name of a product that's on this list, you should be able to identify whether it's open source or proprietary. In the data world in particular, proprietary products tend to be point and click and tend to be made for those who don't know how to program, which can make it hard to customize output. In my experience as a data professional, my rule has always been this. I always prefer open source over proprietary, unless I have to use proprietary software, or if proprietary software can do it quicker for a process that I don't have to repeat in the future. I prefer open source when I need something that I can easily customize, especially if I suspect I'm going to have to repeat the same task in the future. We're going to emphasize open source tools and automation in this class, because you already have the programming background to learn things like R and Python. In the vast majority of situations I've been in, the time I invest into automation has always been worth getting a complicated process automated that I don't have to point and click to replicate in the future. I have seen processes that take 3 hours through point and click reporting in Excel that have cut down to 5 minutes automated in R. Investing the time now to practice automation of data reporting and analysis is a valuable skill to have, and it will distinguish you in a job market where most people prefer point and click tools. Let's talk about the core tools of a data professional. You need a data querying tool to pull data from a database. In this class, that tool will be SQL, more specifically T-SQL. You need a tool that can manipulate data and get it in a clean format. In this class, I'll be covering base R, dplyr, and data.table, which are 3 packages inside R. The equivalent of these 3 tools in Python is the pandas package. SAS and SQL can perform data manipulation as well. You can also use Access in Excel, but as I've already mentioned, I'm not a fan of those tools, and they tend to be more difficult to automate complicated tasks. For data visualization, I'll be covering R's ggplot2 package in this class. The equivalent in Python is matplotlib. I've also had experience with d3.js and Tableau, but will not be covering them in DSci 2000. These 2 tools are really meant for interactive visualizations, whereas ggplot2 and matplotlib are meant for static visualizations. D3.js, by the way, is built on top of JavaScript and SVG. If you're familiar with JavaScript, that's a web development language. If you want to learn an extremely flexible yet difficult programming language for creating data visualizations, try learning D3.js. Tableau, if you're not familiar with it, is a proprietary data visualization product, particularly for interactive data visualizations. For statistics, R is of course built for statistics. SAS is the same way as well. In Python, you have the stats models package. You also need a reporting tool as a data professional. R, in my opinion, does this better than any of these other tools. In DSci 2000, I will be teaching you R Markdown, which is a hybrid of R and Markdown compiled using the knitter package. LaTeX, which is primarily used for typing math equations, can also be integrated with R Markdown. I will not be covering LaTeX in this class unless by request. Lastly, you need a version control tool. Version control, in case you're not familiar with it, is a way of tracking changes to code you make. In particular with Git, what you can do is when you make a change to code, you can timestamp and add a descriptor explaining what it was you did with the code. You can also keep old versions of code in case you need to recall a prior version of code. Version control is very important in software engineering. I personally use version control for everything, including these slides, but from my experience, it hasn't been as widespread in data science. I will also be teaching you about regex toward the end of the semester to do advanced string manipulation, which is provided within R and Python. Regex is not traditionally taught in data science programs, but I've used it enough in practice that you should at least know about it. In the next unit, I will be teaching you how to install some of these tools. SQL Server Management Studio is software you can use to easily visualize a SQL Server database and the tables within it. RStudio is where you will be writing all of your R code. You will be tracking all of your code in Git and submitting your code to your own private GitLab portfolio. Once you're done with this class, you can, if you wish, use your GitLab portfolio as a way to show off your work to future employers. I will also be covering Access in Excel, showing point-and-click versions of tasks we will have done with R. By the way, for Mac users, SQL Server Management Studio and Access aren't available. Neither of these are essential tools to do well in the class. They're mainly covered so that you know they exist. To substitute for SQL Server Management Studio, I am currently exploring a substitute called Azure Data Studio, which is available for Mac. Don't worry about Access. I will not be asking any of you in this class to turn in any Access files and will only be demonstrating tasks and giving you written quiz questions on Access. To end this lecture, I want to make you aware of some history. Those of you who may have a software engineering background may know about GitHub. If you want to use GitHub, you may. Just let me know if you decide to. Given my prior experience teaching this class, GitLab has more flexibility with collaborators that GitHub doesn't have, hence I switched to GitLab for DSci 2000. Prior to October 2018, GitHub used to be its own company until Microsoft bought GitHub. Long story short, people did not trust Microsoft with their code. Many developers ended up leaving GitHub and moved on to GitLab back in October 2018. I can tell you anecdotally from going to local meetups that GitLab is definitely getting more popular. But if you want to use GitHub, you may. The functionality is essentially the same as GitLab. Just contact me if you end up opting for GitHub.